Now we are going to work on the extension part of the problem, which is going to be based on data that I gave you. And that says that the initial value, velocity of the truck here is 40 meters per second. And we have a made up value for the mass, which is 4.0 times 10 to the third kilograms. All right, to figure out what the final velocity is, we have to recognize that the work done is going to be equal to the change in kinetic energy. That's the work energy theorem. Here it is, symbolically. Work is equal to the change in kinetic energy. Work is equal to change in kinetic energy is just going to be final kinetic energy minus initial kinetic energy. And what we recognize is that the velocity is embedded in this term right here. Each of these terms has an embedded velocity. So we're going to have to blow those up and then rearrange some stuff algebraically to figure out what the final velocity is. So work here is going to be 1/2 mv final squared. That's what we're looking for. Minus 1/2 m times v naught, our initial velocity, squared. All right, just doing a little bit of algebra here, a little bit at a time. We'll say work is equal to 1/2 m times the quantity v squared minus v naught squared. Multiplying each side by 2 over m, we get 2 times the work, and this is the work done by the brakes. That would be more fair to put in there, which is in fact the net force acting on the truck. So we know that the total change in kinetic energy is going to be equal to the work done by the brakes. So we get 2 work done by the brakes over the mass of the truck is equal to v squared minus v naught squared. Still trying to isolate v squared. We could say that v squared is going to be, I'm just switching sides here, equal to 2 work times work done by the brakes divided by the mass of the truck, plus we added v naught squared to each side. So now what we're going to do is just take the square root. V, take the square root, means we take that away. V is equal to the square root of 2 times the work done by the brakes divided by the mass of the truck, plus the initial velocity squared. And now, you can see back here that we could put an expression in for the work done by the brakes. This would be the most proper way to do it. Here's work done by the brakes, and we would just put this FD cosine theta in there. So even though the numbers turn out relatively clean, because 850 times 3 is a nice even number, let's just go ahead and do it the correct way, which is going to be to say FD cosine theta in there for work. So now, substituting, we're going to say velocity is equal to the square root of 2 times the force of the brakes times the displacement times the cosine of the angle between them, which we'll just go ahead and remember that's 180 degrees, over the mass of the truck, plus v naught squared. That's our initial velocity. So there it is algebraically. So we're solving for any problem of this type. Now we'll go ahead and put in the specific numbers that we used for this one. Velocity is equal to the square root of force of the brakes, 3.0 times 10 to the third, 3.0 times 10 to the third newtons, times our displacement, which was 850 meters, times the cosine of 180, 180 degrees, which is -1, over the mass of the truck, which I gave as 4.0 times 10 to the third kilograms. Let me check that. 4.0 times 10 to the third kilograms. All right. And from all of that, we are going to subtract v naught squared, which was 40 meters. Oh, we're going to add that, sorry. 40 meters per second squared. And we're going to take the square root of all that. All right. Velocity needs to be in meters per second. Let's check ourselves dimensionally. All right, we know that we should have on the inside, we should end up with meters squared per second squared because we're taking a square root. So we know we're good over here because meters squared per second squared comes out cleanly. What do we have here? Newtons are equal to kilogram meters per second squared times meters is going to be equal to kilograms meters squared per second squared divided by kilograms. Looks like it's going to work out. We're going to kilograms. This is going to be meters squared. We'll just put this up here. And meters squared per second squared plus meters squared per second squared square root meters per second. Good to go. All right, now let's look at our numbers. Looking at the exponents, we can see that the powers are going to cross out. That's pretty easy. And then, so we got 6 over 4 is 1.5. 1.5 times 850 is 1.5 times 1225, right? 850 and 425, 1275. Plus 440 squared is 1600. So we're going to get the square root of that. So that's around the square root of 325. 18 squared is 324. That's perfect. All right, so our final velocity is going to be very close to 18 meters per second. Very close. For all intents and purposes, let's call it 18 meters per second. So that's the speed that the truck would be going once it had applied its brakes over a distance of 850 meters, as given in this this drawing right here. Okay, initial velocity 40 meters per second. This mass breaks this much force over this distance. We'll slow it from 40 to, we just figured out, 18 meters per second when it has gotten to this point right here.